Hello friends, today we are going to cover the first chapter, which is Introduction to Java Serialization. Suppose I have got a very basic Java Pojo object, which is say order. This is order that we use for trading. And it has got a lot of private fields like a long order ID, a double of order quantity, price, order time, and it has got reference to other objects as well. For example, we have got order status, order type. Order status can be another class, or it can be also order type can be also something else. And we want to have a system like this where we have got order OMS and exchange. So OMS from order management system, we are sending these order objects to exchange via network, and the order can be a new, amend, or cancel. Similarly, once we send the orders to the exchange, we expect some acknowledgements back. Suppose I send a new order, I would expect an acknowledgement, or if anything is wrong, it will reject the order. And similarly, we can get a fill also. And suppose the order is still open, and we just can replace the object with say other order quantity or other order type, or we can finally cancel the order as well. So suppose we have got this type of scenario. Now let's take one example of a typical trading day when the market hours open in the morning, and the OMS starts sending the orders to the exchange, and everything is going on well. We are getting the acknowledgements or fills back. But what happens suddenly that we have got a bad situation where our OMS goes down due to whatever reason, whether it's infrastructure or whatever. So for example, there are few orders which are already open, which means that they are neither rejected or filled, and exchange has been sending a fill on it. But because the OMS is already down, we don't know what's the current state of the order. It can be a new ACK, or it can be an amend ACK, or whatever. And in that case, it's a very terrible scenario, because if we restart the OMS and we don't know what was the previous state of that order before it was shut down, maybe it will try to create the other order from the scratch. So here is a problematic scenario, right? That we don't know what was the previous order status when the OMS went down. And whenever we get a reject or a fill back on that particular order, we are out of track. We don't know what's the status of that order. So here we need a scenario that we should be able to save the state of the order to somewhere, so that when we restart the OMS, we should be able to get that order object in the same state as it was before the OMS shut down. Otherwise, it would be totally out of sync. The status would be out of sync, and the whole trading flow would be in a problem. So what are the various ways where we can do this? So either we can use the IO stream classes like file input stream, file output stream, and we save the state of the object every time. Save of the order object, say into a CSV file, which is comma separated file, or we can use an XML or JSON or a plain file, right? Plain file text. So these are the various ways. But when we serialize it, say to a JSON, for example, or to a XML, when we serialize it, serializing means that we are saving the state of the object one by one. For example, if you are saving the object of order, say, we have to save the order ID, order quantity, price, etc., right, in the same order. And also we have seen that it can have reference to other enum types or other classes like order status, or we can say that it's actually an object graph, right? So it would be very tedious, right, to save all the state. And when we are trying to when we start the OMS again, in that case, we have to write a parser so that we can read all this object and rebuild that Java object in the same order as it was there. So there's a lot of manual work required when we take this type of approach to use a CSV, XML, JSON, or any other various format. We have to write the code to encode this Java object into a particular state and put it here in the file format, and then we have to write a way to decode that values and rebuild the object manually, which is very, very error prone. Now, this is where Java serialization comes into place. Now, Java has provided us this serializable interface in the very earlier version of Java, through which we can just serialize any object that implements this serializable interface and turn it into a sequence of bytes that can later be fully restored to regenerate the original object. And we can also send this object once we serialize. So let's go to this like diagram here. So we have got this Java object, similar like order. So using this serialization interface that the JVM provides us, we can just implement the serializable interface and use ObjectOutputStream and ObjectInputStream to write the objects. So what it does is that it converts it into stream of bytes. Now this stream of bytes can be stored either in a file or in a database or memory or the network, right? And it can there might be some other JVM process running on a different host if you're passing through the network, right? And there we can just use the ObjectInputStream.readObject, the API which is provided by Java, to decode the stream of bytes and convert it into the original object. Now, this host can be anything. It can be, for example, we are sending this order using on Windows machine, and the deserialization is happening on a Linux machine. Also, there might be difference in the byte ordering or anything, but this is all taken care of. Once we convert the stream of bytes, this stream of bytes is independent of any host environment or host anything, and it can be passed and deserialized in a very simple way. The magic of serialization, just happens with just two methods: ObjectOutputStream.writeObject, which serialize our objects and write it to the stream, and second, to read the stream and deserialize objects, where we use ObjectInputStream.readObject, and we can reconstruct the same object in the same state as it was there. Just to make a small note here that once we serialize an object and once we deserialize it to reconstruct the object, the new object which is created after deserialization, that is a copy of the original object. It's not exactly the same object. So in other ways, we can also say that besides having the new operator, so normally when we create a Java object, it's a new object, right? We create a new and an object. But there's another way that to create a new object, another object is using the deserialization technique, because it's just a copy of the original object. It's not exactly the same object. So guys, in the next video, we will open our IntelliJ and we will start writing the code, and where we will cover our very basic implementation of this flow, where we are going to the file and then we are constructing this. So we convert this object into stream of bytes, store it into a file, and again deserialize it using stream of bytes, using the ObjectInputStream.readObject, and reconstruct the object. So see you all in the next video.